Have you ever had a numerical discrepancy in your model that you didn't know how to investigate? Is there something you can do besides log all your signals and then search for the needle in the haystack of data that might give you insight into the problem? There has to be a better way. Hi, my name is Sarah. In this video, I'll show you how to debug your model by using conditional breakpoints, stepping through major time steps, and visualizing how signal values change as you step through the simulation. Let's start with an example. This model has a numerical issue I need to investigate. Before we start debugging, let's enable fast restart to keep the model in a compiled state and avoid costly compilation time since I know I'll run multiple simulations while debugging. The issue in this model is in the algorithm the referenced model implements. The scope displays the signal of interest, which I expect to be sinusoidal with an amplitude of 0.1. But, as you can see here, at around 5 seconds there's a huge negative spike that makes the signal appear non-sinusoidal. So where do we start trying to diagnose the issue? Well, we can add a conditional breakpoint to the signal to detect when the value makes this large deviation from our expectations. To set a conditional breakpoint, select a signal. Then, on the Debug tab, click Add Breakpoint. In the window that appears, specify the condition and value. For this case, let's configure the breakpoint to pause the simulation when this signal value becomes smaller than -1000. You can also add breakpoints to other parts of a model, including code inside a MATLAB function block and in state flowcharts. Now, let's open the breakpoints list so we can monitor and edit our set of breakpoints. You can easily navigate to a breakpoint by clicking the hyperlink in the breakpoints list. For the numerical issue we're investigating, I don't expect the issue to be in the MATLAB function code or the state flowchart, so I'll disable those breakpoints. Now, let's add port value labels so we can see the signal values. To add port value labels, select the blocks or signals of interest, then, on the Debug tab, click Output Values. We are almost ready to start debugging. Before we simulate, let's configure the simulation stepper to allow stepping back. This way, we can move backward and forward in time around the breakpoint to investigate what is happening in the model. Now, let's rerun the simulation. Because we already ran one simulation with fast restart enabled, the model is still compiled and restarting the simulation takes minimal time. As expected, the simulation pauses on the breakpoint at the time when the value becomes smaller than -1000. The breakpoint on which we paused is highlighted in the breakpoints list. For this example, we added port value labels before starting the simulation. You can also add port value labels while debugging, including now while we're paused on a breakpoint. When you add a new port value label, it shows the message, "No data yet." The label updates to display the signal value the next time the source block executes. Now, I can step backwards and forwards around this time of interest and observe how the signal values change with each step. The denominator input for the divide block has a value of almost 0 at t=5, which is likely the root cause of the issue. Armed with this information, I can check the parameter values for the upstream blocks. Now, I realize the slope value for this ramp block is missing a minus sign. After adding the missing minus sign, when we simulate again, the simulation does not pause on the breakpoint condition, and the scope displays the expected sinusoidal output. To summarize, conditional breakpoints are an effective tool you can use in conjunction with the simulation stepper and port value labels to diagnose numerical problems in your models. So give these tools a try. Doc links are provided in the video description below for further details.